In April 2026, India officially unveils the B-28, a high-speed bullet train manufactured at a new facility in Bengaluru. This milestone contradicts the legal framework India accepted years earlier. When the Mumbai-Ahmedabad high-speed corridor was first announced, it was backed by a historic, highly restrictive agreement with Japan. Japan provided a massive 88,000 crore rupee loan at 0.1% interest, but it was a tied loan. The terms mandated that India purchase the tracks, the signaling, and the rolling stock exclusively from Japanese companies. India has managed to bypass these legal restrictions to build its own high-speed rail empire, a move that required navigating the intense competitive pressure Japan was facing across Asia. By 2017, Japan was looking to secure its regional influence after a major loss. 2 years prior, Japan had spent months securing a bullet train project in Indonesia, only for China to swoop in at the last minute and take the deal. When Japanese firms refused to lower their prices for the Mumbai-Ahmedabad project, India used this regional rivalry as leverage. Negotiators opened talks with European rail giants like Siemens and Alstom, signaling that they were willing to walk away from the Japanese deal entirely. Facing the prospect of losing another major market to a competitor, Japan capitulated. They lowered their prices and offered India the unreleased E10 Shinkansen, technology that had not yet entered commercial service in Japan. India utilized Japan's need for a strategic partner to extract top-tier technology at rates usually reserved for older systems. While the geopolitical negotiators successfully secured the top-tier tech, the structural engineers had to face the 58-kilometer corridor's extreme geography. The project stalled at Thane Creek. The original elevated track plan would have cleared 21,000 mangroves and disrupted a sanctuary hosting 100,000 migratory flamingos. When the Bombay High Court blocked the clearances, the entire route had to be reimagined. To preserve the sanctuary, engineers shifted the route 114 meters underground, boring a 21-kilometer tunnel directly beneath the Arabian Sea. This requires 3,000-ton machines, capable of withstanding massive hydrostatic ocean pressure while crushing solid rock. Environmental protections forced Formia to master these complex undersea tunneling techniques much earlier than initially planned. These engineering pivots, combined with long delays, caused the project's budget to grow from 1.08 lakh crore to 1.98 lakh crore. To understand this cost, compare it to the high-speed line in Indonesia. That project was built across relatively flat terrain, avoiding the massive concrete pillars and extreme mountain boring required for the Indian route. This chart shows that despite the extreme geography, India's cost per kilometer is approximately $47 million, lower than the $48 million per kilometer spent on Indonesia's simpler route. While the engineering is efficient, the total budget ballooned due to years of administrative friction. Fractured local land politics, widespread local farmer protests, and long corporate legal battles kept the project at a standstill while costs rose. Between the extreme requirements of the undersea tunnel and the years-long delays from land acquisition, the project faced a steep financial penalty for its combined technical and political complexity. That 1.98 lakh crore purchase includes an entire permanent domestic technology ecosystem. Part of this investment is in human capital. Currently, 1,000 Indian engineers are undergoing direct certification from Japanese experts, while pilots train on advanced simulators in Vadodara. This allows India to absorb the Shinkansen's safety standards, a system with a 60-year record of 0 passenger fatalities. India used the Mumbai-Ahmedabad project to train a first generation of domestic high-speed rail specialists. This expertise is now being applied to a 4,000-kilometer national grid. The government has already committed 16 lakh crore rupees to 7 new corridors connecting the entire subcontinent. One of these routes passes through the Siliguri corridor. Establishing high-speed rail here ensures rapid troop mobility to the northeast through a critical geographical choke point. This focus on domestic needs is why the B-28 is capped at 250 kilometers per hour. Limiting the speed is a deliberate optimization for India's closely packed stations, where higher speeds would lead to excessive energy consumption and maintenance costs. By leveraging a regional rivalry to fund its own technical education, India is positioning itself to eventually export high-speed rail technology to other developing markets.